Hello and welcome to this video series. In this video series I want to talk about how to customize Scikit-learn. You can find more information about this also in the developer's guide of Scikit-learn. If you want more information you can click on this link. Now, what is the aim actually of this video series? The aim is that you are comfortable creating your own Scikit-learn classes. So this means you can create your own versions of a linear regression, logistic regression, whatever you want. So these would be predictors or transformers like a PCA or feature selection or something else, and much more, of course. So this is the aim. How can we achieve this aim? So first we need to talk a little bit about the steps we want to do today. Today we want to understand what objects and classes are, and then talk a little bit about Scikit-learn specific classes and how this interconnects to Scikit-learn. If you already know about objects and classes, you can also skip to this minute. Now, what are classes and objects? Here I try to represent a class. A class is something like a template you create to create different objects. Each object should hold a state, so variables inside, and methods which can be used as functions to perform specific tasks. For this reason, you define these things inside of the class itself first. So you create variables and methods inside of the class, and don't worry, I will show you an example very soon. And then you also create at least a constructor in the class, which means what should be performed to create actually an object from the class. And what is now the object? The object is now an instance of the class. So this is one container created by this template. You can create multiple of these from one class, and they are each separate from each other. So they are independent of each other, but all can use their states, which they saved, to perform the actions defined in the class. This seems very complex, but if you look now at an example, you will see that it's quite easy actually. So this is an example. Let's say we want to look at scientists. So I say, I have the class scientist, double point. And now I create the constructor. What happens if I call scientist parentheses? And what this is the initialization method. So this is predefined by Python. Then you say self. You always say self in a method from a class. And this self represents basically later the instantiated object. But you will see that in a second. And then you provide two arguments which define scientist in this example. This is just an example, don't worry. But here I say that the reading speed and the writing speed of a scientist defines the scientist. So I store these variables in self.read speed and self.writing speed. This means now that I can create different scientists from the scientist class. So the objects created from the class now represent different scientists. For example, Einstein, who I just randomly said has a reading speed of 2 and a writing speed of 0.5. Or Marie Curie, who then would have a reading speed of 1 and a writing speed of 3. Again, these are random numbers. They don't mean anything. It's just an example. The important part is now Einstein and Marie Curie are both scientists, but their reading speed is independent of each other. The same for the writing speed. If you want to access actually these variables from Einstein or Marie Curie, we can just say Einstein.reading speed or Marie Curie.reading speed and then get here the reading speed. And the same with the writing speed. And basically that's what I just meant with self stands for the object later. So Einstein would here be the self. So if I say self.reading speed, I basically get what's inside here after initialization. Okay, until now this is not really that helpful, right? Now we have a scientist. Okay, the scientist keeps a state inside, the variables, reading speed and writing speed, but we are not doing anything with that. So let's now do things with that. So again, we create the constructor, but now we also add additional methods. Read papers and write papers, or read paper and write paper. In this, we actually provide the length of a paper, and then we perform a computation on that using the stored variables. So I just say the reading paper, like how long it takes to read the paper, is the paper length divided by the reading speed. And let's say these are pages, so they only can be integers. And the same with the writing paper method. Again, these are just examples. It doesn't mean anything, but now you can see what this means basically in our example. So if I look now at Marie Curie again, I again initialize Marie Curie with some random values. And now I can say something like, okay, Marie Curie has to read now a paper. and she reads a paper of a length of 100 pages. How long does it take her? Well, 100. Like, let's say 100 minutes, for example. Again, the measurements is not so important, but now this can help us to compute things. And the interesting part is we can do the same for writing paper or for Einstein, for example. So you can see it like if she writes a paper, then of length of 100, it takes her, let's say 500 minutes. Again, this would be insanely fast and not really realistic, but it's an example. So let's go on. We can now even change the state inside of Marie Curie. Let's, for example, say before she had a writing speed of 2, and now I changed it to 100. So I set Marie Curie writing speed to 100. This means I just changed the state inside of the object, which means that if I now perform the method write paper, it will use this new state inside of Marie Curie and give us the appropriate answer, which means now she can write a paper in 1 minute. This might already tell you why this is important for Scikit-learn, where we basically want to fit a model or a class especially on data, change an internal state, the coefficients, and then use methods like predicting. But more to that later. Because now we also want to talk about classes and inheritance. This is another concept which will help us to use Scikit-learn's classes, which they provide, to inherit from them and get easier results. So, what's the problem here? The problem is, let's say that we want to create now a class called PhD. And we say a PhD is a scientist, but not all scientists are PhDs. So a PhD should be able to do what a scientist can do, but not everything, not every functionality a PhD provides has to be there for a scientist. So now, how do we do that without rewriting the complete scientist class? And for this, we can use inheritance. Basically, what we want to say is a PhD inherits functionality and variables from the scientist class. Conceptually, we can look at it like this. We have the class from before, like some class. Now we say this class should be a superclass, meaning another class inherits from it. It doesn't change anything about the class itself, but how we look at it. So now I say another class, here called the subclass, is inheriting from the superclass. So the subclass inherits from the superclass. This means that the subclass now inherits, so gets all the methods and variables and states and stuff like this from the class, unless you overwrite it. And then we can create, for example, again a constructor or even inherit it and create new objects from this subclass. And now the interesting part is that the objects here, D, E, and F, are instances of the subclass, but also the superclass. Again, the concepts seem quite complex, but with an example it gets much easier. So let's look at that. Classes and inheritance, our example. We have now the PhD. And using these parentheses, we actually inherit from the scientist. And then I just say pass. Pass basically means I do nothing in Python. Okay, so now I have a class where I specified nothing except that it inherits from scientist. Okay, what does this mean? Well, this means that basically now I can create PhDs with the same way as I did a scientist, because basically a PhD right now is just a scientist. For example, here I can create the PhD Hans, and Hans has a reading speed of 5, a writing speed of 0.05, and then when Hans writes a paper, it takes him quite long because of the writing speed. Nothing new here, just that we never specified these variables and methods in PhD and just got them free from scientist. Again, what we want to show is that Hans is an instance of the PhD and the scientist, as I mentioned before. This is quite nice, but of course it doesn't really add something to the scientist yet. So let's do that now. Now we have a PhD, again inheriting from scientists. This time we create a new constructor. This means this constructor overrides the inherited constructor from scientist. So if I define a method which is also in scientist, it's replaced by the new one. In there I put again the reading speed and writing speed, but also % funding time left for the PhD. So how long until your deadline basically. Then I manually say super parentheses dot init. This refers to the initialization method of the superclass, so of scientist. Basically what I do is I create now the scientist and just giving it the reading speed and the writing speed. I could have also just said self.reading speed equals reading speed and self.writing speed equals writing speed, but this is a little bit easier. So don't worry, this is just a help part for you. You can just call the initialization of the superclass, but you don't have to. Then I add also the extra variables I added for the PhD. Here, self.percent funding time left. And then I also add a new method, this one. I say the method calculating the existential angst of a PhD. And in this, we set a variable, let's say in pandemic. By default, it's false. And I just say, like, if it's in a pandemic, like if we are in a pandemic, then basically the existential angst is always infinite minus self.percent funding time left. And I think you can already imagine what this means. It will always be infinite. And else, if we are not in a pandemic, then actually it's like 100% basically minus the percent time left of funding. In the other way, the existential angst increases the closer you get to the deadline. Our example, as before, we can now initialize Hans as a PhD. This time we have to add percent time left funding, right? Then I can still say like Hans writes a paper and we get the output, but now I can also say we want to calculate the existential angst of Hans and we are not in a pandemic, so it's at the beginning just 1 because we initialized Hans with a 99% left of funding. Seems good. Now let's change that, of course, because now half of the time of the funding time is gone. So Hans is in the middle of his PhD. So if we now calculate the existential angst of Hans, not inside a pandemic, so outside of a pandemic, it's around 50% existential angst. Of course, again, if we are in a pandemic, then it's infinite. So what we've seen until now is the PhD got all the functionality from the scientists. We were able to override things that are special to the PhD and also add new methods in the PhD. And this gives us now our interim summary. Classes are great tools to create stateful objects. We can store variables, use methods on these variables, and create structure in our coding. Using inheritance, we can improve this even more. We can get a lot of code for free and do not have to repeat it, especially when Scikit-learn provides us with good super classes. And now we are ready to look at Scikit-learn itself. So what about Scikit-learn actually? Why did we go through all of that? Well, Scikit-learn is a machine learning library which is based on classes and objects. There are multiple very important classes in Scikit-learn. So for example, estimators, predictors, transformers, and models. So let's now look at the Scikit-learn estimator, because a lot of important classes from Scikit-learn are based on the estimator. So they inherit from the estimator actually. The estimator is to be defined by its method. It basically always has a fit, getParams, and setParams method. Fit just means we are fitting the estimator to the features, so x, and the target y. Meaning we change some internal states, some coefficients, and that's it. We are fitting the data. Then we have getParams and setParams. This is specific to Scikit-learn again. getParams returns all the parameters you set in the initialization method, so the arguments we provided there usually, and setParams allows you to change them afterwards. This is important for things like copying estimators. Then we have Scikit-learn predictors, for example, which add a predict method, transformers adding a transform method, models adding a scoring method, and much more. So let's look into an example of Scikit-learn estimators. This is my dummy estimator. I created this estimator just to fit the mean or the median of the data, nothing else. We just create an initialization method where we can set one parameter, use median, equals to false or true. And we set it into the class, of course. So then our object would have the variable use median. Now we can fit it. Basically, we just say, if it's use median, then we set value underscore to np.median, and else we set value underscore, so self.value underscore to np.mean. So the important part here is, like, this parentheses at the end of a variable indicates in Scikit-learn that we look at a coefficient of an estimator. So something that's trainable. This is just by convention. You don't have to do this, but it's good practice to do it. Then we have getParams. We only have one parameter, as I've said before, so the variables inside of the initialization method, and we just put it into the dictionary with its associate value. We will ignore deep for now. setParams just provides you some keyword arguments, and you then just set these parameters. This part is not so important right now, because as you will see in a second, we don't actually need to write this boilerplate code. It's boilerplate code because you always have to write it, and it's very similar. You just have to plug in the initialization parameters. So how can we get rid of this boilerplate? We can just inherit from the base estimator. The base estimator is defined in Scikit-learn base. We can import it, just plug it in here as a superclass, and now you are rid of getParams and setParams. That easy. Now getParams and setParams works automatically using the arguments you set here, so the parameters you set here. And just to show you, if I now initialize an estimator from my dummy estimator using the median equals true, then you can see getParams gives me use median true, as we've seen before getParams should do. Now let's go on to the next example, because just an estimator seems boring, right? Like we just fitted the mean or the median, but we don't do anything with it. So let's look at my dummy predictor. This is now a predictor using the mean or the median. We just output the mean or the median for all data points we get. For this reason, we have the same initialization method, the same fit method, but now we add the predict method. Again, starting with self as every method, and then inputting the features. So x. And then we create the output by just saying, okay, we want an empty array of the length of x, right? And now we fill this actually with self.value underscore. So with here, the median or the mean, respectively. Perfect. And that's actually our prediction. That's how easy it is to create a Scikit-learn predictor. As you can see, it's not a lot of code. So now a couple of examples again. So we just have here the features. We define it as some array, right? That's not so important. Then we create also the y. We set the last one to an extreme value just to see the difference between mean and median. And now let's look at our estimator. As you can see, I said estimator, by the way, because a predictor is an estimator. So I can also say, let's look at our predictor. But as I said before, inheritance means predictors are estimators. So let's look at our predictor. The predictor, my dummy predictor, with using the mean, not the median, will predict always the same value, which is actually the mean of our data x. If I now initialize our dummy predictor with median to true, then it will actually give us the median, of course. And that's how easy it is. If we now look at a model, for example, we can do the same. We again extend our predictor now to a model, which just adds the scoring method. For scoring, it just means you predict and then you look, how far am I away from the target? And for this reason, we can just import the R² score from Scikit-learn and just plug it in here. We create the predictions with self.predict. So as you can see, we can call a method of the class inside of the method of the same class, but another method. So self.predict, give it x, and then get a prediction. And now we just plug in the prediction and y into the R² score. And just as I look now, you see it? There's an error. For R², you actually have to put the true value first. So let's just change that for now, and then the prediction. So, sorry, my bad. This is the correct way. But again, this is just like some technicality of the R² score of Scikit-learn. So it doesn't have anything to do with objects and classes itself. So okay, let's just create this and go to the next one. But as you can see, now if we get the score, like we initialize the model and now get the score, then you can see we get actually a very bad R-square score, which makes sense. Just predicting the median or the mean is not that good. It should be roughly baseline, and that's what we see here. Okay, that was just like for the outlook for the future, what we will look about more in the next videos. Also, this last part is also just an outlook. So I just want to show you can now use our dummy model, for example, in the cross-file score method of Scikit-learn, which does cross-validation for you and gives us scores. As you can see here, just redid it like that was with the example before where I computed R-square wrongly. It gives us quite high errors as you would expect. Okay, summary, what did we learn? We actually learned that customizing Scikit-learn is quite easy. You just need to understand classes and how they are arranged in Scikit-learn, at least a little bit. Most importantly is that we can use the base estimator and estimators in general to create other classes, inherit from them. The base estimator or an estimator generally just needs fit, set params and get params, and set and get params is basically given to you by free if you inherit. So that's basically it for what we have done today. And then in the next videos, we will look a little bit more into Scikit-learn, take a deeper dive into it. First, maybe let's say at predictors and models, then at transformers, which are quite interesting, and maybe afterwards at custom compositions, though this might change if I see that it doesn't fit that well into these videos. Thank you very much for your attention and have a nice day.